Now, when we talk about energy, we remember that there isn't just one type of energy. So let's remind ourselves about the different forms that energy can come in. We know that energy can be, for example, kinetic energy, thermal energy, nuclear energy, magnetic energy, elastic energy, gravitational energy, or one of many other forms. So that's a load of different types of energy. Let's focus in on a couple of them at random. Let's talk about elastic energy, for example. Elastic energy is the energy stored when we try to stretch a spring. And we certainly know that energy is being transferred when we try and stretch a spring, because we know it takes a lot of effort to do that. Okay, let's talk about one more type of energy. Let's talk about magnetic energy. This is the energy that is stored, for example, when we try to pull apart or put together two magnets. So let's imagine we were trying to pull apart these two magnets in particular. There's a north pole here and a south pole here. And we'll learn in our videos about magnetism that this means that these two magnets are being attracted to each other. So it takes effort to pull them apart. There's energy being transferred when we try to pull them apart. Let's focus on two other types of energy. In particular, we know that there are equations for the kinetic energy and the gravitational potential energy. So let's look at those. We know that the kinetic energy depends on the velocity of an object. That's because the kinetic energy is the energy associated with an object's motion. So let's imagine we're talking about the kinetic energy of a car. Let's say the car is moving with some velocity. Then if we know this velocity and we know the mass of the car, then we can calculate the kinetic energy of our car. We find that it's equal to 1/2 multiplied by the mass multiplied by the velocity squared. Now, the other type of energy for which we currently know an equation is the gravitational potential energy. We know that the gravitational potential energy of an object depends on the height of the object above the ground. For example, we learnt that lifting an object higher above the ground, for example from here up to here, will increase the gravitational potential energy. In other words, the gravitational potential energy depends on the height of the object. We also know that this gravitational potential energy will depend on the mass of the object. And at this point, I think we can write down the whole equation for the gravitational potential energy.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.